Our two speakers today are Steve Scanlan and Alfred Thompson. Steve did a bachelor's degree in Spanish at Rutgers. And then, well, I was the one in my family, my parents grew up bilingual, so I was the one delegated to learn Spanish so we could all understand what my parents were doing at the table when they spoke in Spanish to avoid having us kids know what they were saying. Bought a Tandy in 1984 and taught himself to program, so like many of us, he did a lot of training on the job.
That's true.
Taught Spanish in ESL, and then set up a Microsoft network, moved into IT, returned to the classroom, and has taught computers since then. And currently, I guess, in Los Angeles.
Yes, Huntington Park, actually.
And Alfred Thompson has been involved with CSTA for a couple of times, because I have seen him at a couple of these meetings before. He is, I can find my, what I need is to have he is the K-12 Computer Science Academic Relations Manager for Microsoft, where he's been the last 7 years. Prior to that, he taught high school computer science and was a school-wide technology coordinator, and maintains a CS education blog at blogs.msdn.com/Alfred.
Alfred, yes.
Alfred TH. And they'll talk about XNA and computer science. So I'll turn it over to you.
All right. We haven't done anything yet. Hopefully you'll applaud at the end. We're going to start with a little assertion. Basically, I'm going to give a little bit of background, say kind of why this should be interesting, and hopefully, I mean, you all have decided for some reason it is. And Steve's going to talk a lot more detail about how he's been using these tools, or a number of tools, in the classroom and using game development as a motivator. We're starting off with an assertion that game development is serious computer science that teaches essential 21st century skills. I've been in the computer business, if you will, since I took my first computer programming course in 1972. And for all of those years, game development has really been pushing the state of the art in computer science. Whether we want to admit it, there's a lot of money and interest in games. Computer gaming, by the way, is a bigger industry than the movie industry, which seems kind of appropriate to mention here in California. 21st century skills. I mean, we're talking about learning innovation skills, information media and technology. We're talking about all of these things that really get integrated when we do teach with game development. So we build upon mathematics. Many is the time I've had a student come to me and say, you know, the boys especially, I want to create a missile game. All right, well, you're going to need some math for that. All right, sciences. You know, we talk about physics engines. We talk about doing things with chemistry, art. Certainly in computer games are when a lot of kids who think they can do everything find out that art isn't one of those things. Other kids find out that, yeah, it is. And then, of course, language arts. A good game, especially, but not just role-playing games, they tell a story. And we find kids at all levels writing computer games that are really stories. And we see that with all kinds of tools, from storytelling Alice to XNA to pretty much everything you can name. One of the things we know, and I'm kind of one of those people who's got a foot both in the academic world and the business world, and I've moved back and forth between them, and now I'm kind of, you know, stretched in between them. But we know that kids today, more than ever before, you know, I heard somebody say kids today are better prepared for the Industrial Revolution than they ever have been before. But that's not really. Today we need critical thinking, we need problem solving, we need communications skills, we need collaboration, we need all of these skills. And fortunately, or unfortunately, depending on your point of view, modern games require all of those things. Especially as you'll hear more about, they're going to require communication and collaboration. Contextual bridging. You know, we deal with time on task, all right? How hard is it to keep kids on task, all right? Now, I don't know about you guys, but when I was teaching computer science, I had kids who would get so wrapped up in a project that when the bell rang, they said, "Can't we stay?" I see heads nodding. When kids are creating a game, it takes it up a notch. But they're motivated. They have strong goals. Kids want to create something that means something to them that they can share with their friends and peers. And of course, as we all know, high school students especially need an infinitely patient medium, because most of us aren't. I'm not. I'm pretty patient, but not infinitely. We're also dealing with, and this is important when you're thinking about computer science, we're dealing with complicated algorithms, complex data structures, all right? And that's important not just in games. Facebook is basically a database application, all right? Facebook is a database application. Twitter is a database application. World of Warcraft is a database application with a really cool front end. All right, so all of these things are behind there. So we deal with object-oriented design, with interfaces. We deal with methods. We deal with behaviors, control structures. I finally got an understanding of object-oriented design when I went to create a game. Do you guys remember the game Simon, where you had the 4 colored buttons? Yeah, when I wanted to do that, and it dawned on me, all right, how do I keep track of all these things? Oh, I create a button object and just tell it to do stuff. So we can really learn a lot. So I don't want to take up too much time because it's probably beneficial for all of us to hear from somebody who's actually using some of these tools, some specific tools in an environment based around computer science and game development. So I'm going to introduce Steve here, who's going to talk about, you know, okay, this is all great theory, right? This sounds great, right? You can push it to your principals and curriculum supervisors. How does it actually work? I'm going to let Steve talk about that.
Thank you, Alfred. First of all, it's a pleasure to be here. I've been teaching in the Los Angeles Unified School District for 25 years. Actually 25 years at the same school. I've been teaching at a school, Huntington Park High School. Primarily Latin, 98%, 99% Latin, lower socioeconomic structure. We have a lot of kids that aren't doing very well. But one of the things that we've had success with is our computer program, at least in terms of having a structured computer program. Let me see if I can figure the buttons. This one right here? That's the button, right?
This button.
Okay, sorry. Okay. All right. I had a mixture of kids. I had a class, and Pat Phillips actually proposed that I start a pilot program, or be engaged in the pilot program that Microsoft was running, to work with C# and the XNA game programming environment. I've been working with Flash for a long time, had done game programming for a number of years, and I'd had some kids ask me, can you program a console? I was like, well, yeah, sure, I probably could program a console. I had no idea how to do it, but I asked the kids last year, or at the beginning of the year, if they would like to work with Flash, you know, a medium that I understood a lot about, or if they would be interested in doing some console programming, some Xbox programming. And the kids said, oh, Xbox programming, how can you do that? I said, well, you can do it. We can try it. If you want to do that, that's what we'll do this year. And we didn't have a game programming curriculum. This was something that we started up this year. I took it from kids that were, for the most part, advanced students. They should have been. Our counseling situation's a little odd sometimes, but they were kids that were in the second year of computer classes. Some of them were in the third year. And I said, well, we can work with Flash and make games there, because I like making games, or we can go with Xbox. And raise your hands if you want to do Xbox. And the vast majority of the kids wanted to do Xbox. Okay, all right, so it's going to be harder. Is that okay? Okay, it might be real hard. I said, all right, okay, so we'll give it a shot. We'll see how it works. Well, it worked out real well. We had a lot of luck with the kids. I had some really good kids in my class. I had actually 2 classes I did it in. I had some kids who were taking calculus. I had some kids who were taking trigonometry. And I had a number of kids that were in special ed and were autistic, very low functioning. And they presented the greatest challenge to me in terms of how to set up the class. And things worked very well for the most part. I could have done better, and that's what happens when you set up a class for the first time. You have to take risks. And I know that next year's class is going to be even better, but we had a wonderful experience this year. I want you to know that. So anyway, I decided that we were going to use Small Basic, and Small Basic is a very stripped down, lean programming environment. I don't know if any of you have used Small Basic before. It's really easy to work with. It's basically designed for younger kids, but if you have kids in a class that have never had exposure to a programming environment, it's very easy to work with. Some of the programming language elements are a little bit odd, but you have graphics elements that are easy to work with. You have for loops, you have while loops, you can actually publish your documents. And there's a good online community with a number of examples. So it seemed like a logical place to start out. And that's the interface right there. That's the GUI. And you can see the little code window, an error window, and a run button, and a couple of other buttons to save and open file folder and start a new project if you like. So it's very, very easy to work with. It doesn't confuse anybody like Flash does. Flash now, CS4, you've got windows all over the place. It's a great language to work with, but you have to really train people how to use the GUI. This one, pretty easy. The difference, of course, is that this is really a command language, command line language. You write things down in sequence. Everything has to be set up with subs. In other languages, you use procedures, and C# you use voids, and you use methods and properties. It's C# is a full object-oriented programming language, like Java, very much the same way. And I did a little teaching in Java. So what I'm saying is, to do this, you have to be willing to put some time in. If you want to teach it, you have to learn it. That's number one. And even though I'm a Spanish teacher, languages has been a fascination with me. Computer languages has also been a fascination with me. So I just have gravitated towards languages for a long time, computer languages. To publish, you basically have to have Silverlight installed on your browser. That's the only requirement if you want to have your games published in Small Basic. And I made a little game. Yes?
Silverlight comes with Small Basic?
No. Okay, Silverlight's just built into the browser. Basically, if you're using Internet Explorer, Silverlight will be installed in one of the updates. So it's not an additional.
Downloadable from the internet?
Yeah.
It's a plugin.
It's a plugin. It's just a browser plugin. It's available for most internet browsers. It's a media player like a Flash player or something.
You probably have it installed and don't even know it. It's there. So this was a little game that we did. It was a relay race, a little truck race. And you can see the extent of my wonderful graphical abilities. Okay, those are my trucks. And they went from one side of the screen to the other side of the screen. It just showed what happened, how you can have an object pass another object and detect on the screen their locations, which becomes very important when you're developing a game. You have to know where things are to be able to tell what things should be happening at what time. So that's just an example of what you can do with it. And this is a little code sample. You can see there are arrays inside this language, but they're not declared. It's a little bit odd. Like I've got the XPOS array, and I've got those are numbered, and the YPOS array. Okay, you don't have that's the full declaration right there. There's an example of a sub. There should be an end sub right there, but that's off the screen somewhere. But if you take a look at the for structure, for and end for, kind of an odd structure. But you've got a shapes object, and you can add images to the shapes by passing a path, and the path is actually a variable. And load up your images and make them move. Okay? And so that's just a little piece of a program. Maybe I'm not even sure it's that one, but just a little easy demonstration of how to move things around. IntelliSense. How many of you know what IntelliSense is? A few people. IntelliSense is contextual. Other contextual clues. If you type something like I had to complete my for loop and I forgot that it was N4, actually I didn't really, but I pretended I did. N4 is the structure that ends your for. So it will help you. It will give you clues. There are only 16 major programming definitions that you use with this language. So that's another thing that makes it easy to work with. You start with a very limited set of instructions, and then you can teach the kids a lot with that. Okay. All right. Another thing, you can publish these programs. Okay. There's a little button that says publish. You click on the publish button, and it'll take you to a website, and it'll give you a little code number that you can type in, a little URL that you can put in your program or your browser, and you can see your program. And that's what this little program looked like. Just generated a series of randomly colored rectangles, random size, random color. And you can see over to the right, there's embed code. If you want to put that code inside a web page, you can see the same thing. So it gives the kids a chance to look at their work when they're done with it. So it's a little exciting in that. You can do some simple games. Yes?
Is the embedded code in Silverlight? Is that the Silverlight?
Yeah, it uses Silverlight. I think if you can see, I can't see it right here, but there's yeah, there it is, right there. Type equals application, Silverlight. So yeah, if you don't have Silverlight, you won't be able to see it, but you probably do. Now, next thing. Okay, more code. Okay, and you can see here's an array of colors, and that's the actual code that created those random rectangles right there. So you can see it's a pretty simple language. You use the graphics window, and you can use the desktop height and width and so forth, which is a good preview for what you would be doing if you're programming with XNA, because people have to know how big the screen is, how high the screen is, whether your objects are on screen or off screen. So I gave them a little preparation. I even did some collision detection with them in Small Basic before we moved over to C#. Okay. Then we graduated. Okay, I said, all right, you guys, we're almost done with Small Basic. Now we're going to move on to the real thing. So Xbox 360 had these kids motivated. As I told you before, when I asked these kids if they wanted to move over to Xbox, they were thrilled. Okay, they said, yeah, let's do it. Okay, and they stayed thrilled until we finished with Infotech. Infotech happened, I think it was in April, and I got them really motivated to compete against other schools. They thought they were competing against other schools, but they're really just showing off their work to the district. But they were motivated. They were motivated. A little demotivated afterwards, but they had a chance to show the local superintendent Cortinas the work that they did. They had a chance to show off to the other teachers around them, and our booth was surrounded. We had all these middle school kids playing the game that they'd written, and the Infotech people chipped in for a little USB drive to the kid with the highest score, who kept on coming back over and over again. But it worked out real well. They loved it. Okay, that's the whole story about Flash, and they chose Xbox 360, and they chose it because some of them had it at home. They were the ones that took the greatest interest in the programming. It boggled their minds that they were able to actually program that console that was sitting on top of their television set. Really, they were amazed by that. And it gave them a certain prestige amongst their peers. And they saw a clear career opportunity doing this. Now, game programming, there's a lot of people in it. You're not going to be able to make a lot of money with 2D game programming, and you won't be able to get much farther than 2D game programming with Xbox or any programming language right now, because it's very complicated. 3D programming is extraordinarily complicated. So our game was a 2D game, but they were very happy with the results. They did some wonderful work, and hopefully I'll have a chance. I'm talking too much. Hopefully I'll have a chance to show you what they did. Okay, I chose it because Pat Phillips talked to me. We ran a contest a couple years ago about web page development, and the kids I had did a really great job, and they took first, second, third place. And so I met Pat, and she visited our school, and the kids had a wonderful time. So she proposed to me this idea of starting up an XNA pilot, and you got to take those chances. And I'm glad that we did. And because I had experience with game programming in Flash, I thought, okay, I can make the transition. Okay? Had a little bit of programming practice in C#. Not as much as I think Pat thought I did, but I developed some pretty quickly. That was it. All right. Now, where you can deploy it. You make your games on your own computer, and then you deploy it to your Xbox. Okay? You need to have a Creators Club membership, although if you work with Pat, she's here, or Alfred, I'm sure they can get you set up in some way to facilitate that so you can deploy the games that you're working on. I created a couple of games over the summer before I started teaching this class because I had a feeling they were going to pick it, and I was going to kind of drive them that way anyway. I set up a little tic-tac-toe type game just to get used to the interface and so forth. And before you do this, you really have to know more than they do, quite a bit more, because things can get complicated. And you have to be ready for the little problems that you might run into. So I published my first couple of games. Didn't try publishing it on a Zune. You can if there's a Zune. If you have kids with a Zune player, you can publish to a Zune player. And now with the 2010 version, you can publish to a Windows phone. So I think the idea, it's sort of a competition with Droid in a sense.
Droid? Never
Never heard of Droid. The Windows phone, and it's a very versatile media. And I'll tell you one thing, I'm not a shill for Microsoft or for anybody. I've used Java, I've taught. The installation of C# and XNA is a lot easier than installing Droid. If you're thinking about developing for a phone, I know it's a little off topic, but it just is. It's a more straightforward app installation. So anyway, this is a little overview of the environment in C# and in XNA. You have different tabs that will show you the different parts of the program you're working with. Sprite Manager was one part of this program. Scope, Game 1, Explosion. They're all C# basically classes. Okay, and all these classes share a namespace. These are some of the commands. Now, this over here, the Solution Explorer. These are the different resources that you have. Content holds the resources that you load into your game. You have to get them from there, basically. And you have a properties window that will tell you things about each individual object that you're working with. It's very clear. These are the major windows that you work with. The kids get used to it pretty quickly. Let's see. Structure, okay? As I said, Game Studio is an additional framework that integrates with C#. So the first thing you do is you install C#. Then you download and you have those, by the way. On those discs I gave you, you've got C#, the Express Edition, 2008 and 2010. I use 2008. It's the more experienced version. The more, it's not beta. And it works. And the XNA 3.1, very stable environment, didn't have any problems with it. So I would recommend, as of this minute, that would probably be the best environment to play around with. Now, probably within 3-4 months, the 2010 version will be great. But that's how it works. So when you're working with this, okay, you add the framework, the XNA framework, and then you have templates that you can use to create your XNA games. And it extends C#, if you will. Sounds, images are converted into the XNA format that they'll use, XNB files. They have their own particular format. But you can load in GIFs and JPEGs and WAV files and MP3 files, and they'll be converted to the proper format when you compile your programs.
This PowerPoint is available from your website? Or
You've got it on your CD.
It's on the CD.
It's on the CD.
And we send it to CSDA, so it should be on the CSDA site too.
Thank you.
Okay. All right. Okay. A couple of details. Classes must be in the same namespace. So if you can import classes, there are tons of resources out there. I mean, there are just thousands and thousands of resources for XNA, and you can borrow pieces and then change the namespace and try to make your games match. If you understand what that person's doing, you can get other pieces of code to integrate with your own. And that's a very powerful thing to do. I use a scrolling star field background in one of the games that we'll get to see, and show the kid how you can modify a couple of the properties on that to incorporate it into his game. And then he had a whole scrolling star field with a spaceship, and he found another class that could and studied that to be able to fire missiles. And with the collision detection that we already had, he was able to put it together, and it worked out really well for him, and he was very proud of it. He graduated this year, as a matter of fact, and he wants to pursue a career in computers. He wants to do network management, and he's also looking at game production. So, you know, it's great to have kids that like what you're doing. It really pays you. That's what you get paid for. That's it. You know, that makes it worthwhile. Now, there are no timelines. It's all straight programming. So if you understand Java, if you understand, you know, that there are no real shortcuts for this, although this language has all kinds of resources available. It has all kinds of tools that can help you, but it is tough. You know, if you got it's not a low-level thing. Everything happens in a giant timed loop. You have this big loop that executes 60 times per second. So you can create your own timers, and you have to do that. You have to create your own little timers. And there's a great book, and I think my wife has it. Let me just pull this out. This book you have as well. You have the digital format, thanks to Alfred. But this, Pat sent me the hardcover version that is a great resource that goes with this class. It's written with the teenager in mind. It's a fun book. I read it, I had a good time with it. It's entertaining. And Rob Miles is the author. And it says XNA Game Studio 3.0, but everything that you can do with 3.1 is right there. There's nothing that you wouldn't do if you're starting off with the basic 2D game programming environment. So it's a very good book. Excuse me to see if I'm here. Okay, you're going to have it in there. It's called XNA Games. Oh, it's Learn Programming Now. Microsoft XNA Game Studio 3.0 by Rob Miles, I think. Yeah. By Rob
It is
Miles.
on the DVD.
Yeah. Very good book. Very good resource. And whenever I got a little bit too far out in left field, that book pulled me back. Okay, so you have to watch out for that too. You can let your own enthusiasm carry you away sometimes when you do this stuff, but it's a very good book. Let's see what else. Okay, XNA. Using statements, declare all the resources that you're going to load up from the C# environment, basically C# XNA. You declare the library of objects that you need to use with using statements. Namespace, I've said, that basically says this is this program. That's what the namespace does. Then you have class declarations, public and private variables that go in the class declarations. And then there's a section that's strictly for XNA, okay, which is you have an initialize section, load content where you load up your images inside your game, sounds, resources. You unload content section, update and draw, which are very important. Update, it's kind of unique to this language. Your update information is where you'll have your loops and the bulk of your code. And let's say you want a spaceship to move, I don't know, 10 pixels every who knows what. You set up a timer to move that spaceship in a timed loop so it fires every 10 milliseconds or whatever you want, and it moves so much, right? Or you can set up an animated sprite that will take an image and move it in a sequential pattern to make it change the way it looks. So that's what you do inside an update. You can have multiple classes running multiple updates, and the draw renders whatever's happening inside your game logic. You know, once you've made a change to your program, the draw will draw it. Okay? So that's how that works basically. All right. Good teaching strategies. I came up with a whole bunch of good teaching strategies, and I came up with a whole bunch of bad teaching strategies, and I'll tell you both. Okay, first of all, this is complicated stuff. You know, you'll see. When you're working with it, your code gets longer and longer and longer. Now, after you're experienced, the way it is in life, then you can start to put your code into different game components. But that's a complicated process, and that's kind of like a series 2. You know what I mean? So you end up with your programs getting really long. So one thing that you have to do is show them multiple examples. You know, they'll work on one big game, but you have to kind of give them games that are half done and then have them fill in the details so that they can get what you're driving at home to them. That's really important. Give them some samples. Before you dive into XNA, play around a little bit with C#. You I had them work with a web browser. Real easy to load a web browser. It's kind of neat. You've probably seen that before. You load up a web browser, put some buttons on it, have the buttons do a couple of simple functions, and they get the idea that they have buttons that make things work. And it works with this object, and it works with the web browser object, and they get an idea of the power of C#, and that kind of whets their appetite for the game programming that comes along later. So the game loop's kind of a different idea. You've got a form objects, and you've got a game loop that just keeps on going, and all your code's inside that. So, you've got to prep them for it. Okay. Where else are we? Okay. Make sure students know what file extensions are. Okay, because they will load up bitmaps and pings and TIFFs and every imaginable graphics type of format and not understand why things don't work. Okay, so you have to explain. I always turn my extensions on so they can see them, and then run the risk that they'll erase the extensions. But I mean, they have to know what they are. They really do. They have to know what syntax is. They have to know that things happen in order. The basic programming stuff. Like I said, use the book. It really helps you. It's very clear. It's written at a teenager's level, but it explains a lot of the concepts, and it will keep you on track, and you'll learn a lot too. If you just follow the book through, you'll do real well. Download samples from different websites. There are tons of different websites where you can pick up resources. So you can pick up a lot of disparate resources and play around with them. At first I started using the book, and then I started using the O'Reilly book. There's a big O'Reilly book that goes into 3D programming and so forth. And that was when I wanted to really push myself and get ahead. I used that book, and then I would kind of break down the concepts into smaller chunks for the kids. So I would suggest you get a high-level book and use this one to start off with. So you have your guide. Yes. Question.
What's the O'Reilly book called?
That's a very good question. What is the name? What is the animal? Yeah, what's the animal? What's the animal? Oh no. It's that kind of question that derails you. What is the animal? Yes, it does. Yeah, using XNA, I think is the name of it. It's their main one. It's a thick one. And it starts off with 2D. About 25% of the book is 2D, and about the last two-thirds, last 75% is, that's my math. The last part of that book is 3D, and 3D is much more complicated. But if you could have 2 years.
Yeah, there are actually a good number of books about XNA out there from different publishers, so you can probably find them searching Amazon or using your search engine of choice.
Bing, bing. Okay. Other stuff that works. Spend time when you explain how to pass information from one method to another, from object to object. That's very confusing to kids, and how objects can change, how to cast integers and floats and things like that. You have to explain some basic Java type concepts to them. You have to explain what data types are and how to use them. Breaking into teams helps a lot. I had I had the special ed kids, and I wanted to get them involved. I really felt bad for these kids, but some of them were good artists, and they could work together and talk to kids, and find a way to incorporate kids. You can't always find 40 or 35 or 28 solid programmers in any class. Where I'm especially, it's a little bit tough, but you might have 10 really solid ones, and you might have some other kids that are hanging in there, and you might have some good artists, and you get them to work and find ways to get the kids to work on this stuff. Because I found out at the end of the year, I had a couple of kids that, they didn't do great. I think I gave them a C, but, I said, well, did you enjoy the class? Oh, yeah, we loved it. I don't know how much they learned. They must have learned something, but they loved the class. So they got something out of it, even though they didn't produce a whole lot, but some of the other kids did great work. So it all depends upon, you'll get out of the class whatever the kids are able to get out, and you have to find a place to meet them. But they really are intrigued by the idea. So it sells itself in its own way. Question?
What are the prerequisites?
The prerequisites depend upon your school. I would say that the kids should have had some kind of programming class before they've had this one. I would say so. The book takes it from the perspective that it's a first programming class, but there are an awful lot of concepts. And I don't know how fast-paced your schedule is, if it's a 4x4 block or if it's, you know, a traditional calendar or whatever. But I'd say at least if they're exposed to something like structured, you know, web programming, style sheets, HTML, that should be a minimal requirement before you get them going with it. Not because that's a linear part of knowledge, but because they will be exposed to file extensions, they'll know about screen size, they'll know about computer concepts before stepping into a programming environment. Oh yeah.
Would it be possible to do a subset of this post-AP test, which is like about a 5-week period?
Yeah.
So you could, you know,
Yeah.
after AP, this would be, sounds like an ideal
Yes,
exploratory
yes,
beginning.
yes. Oh yeah.
Yeah, there are a number of schools where I've worked with where they have them, you know, 5-6 weeks after the AP, and they are using it. The move from Java to C#, most kids, especially if they're in an AP course, you know,
Yeah.
it's Snap, you know, and you know, they know how to use an IDE, they know, and it looks a lot similar. So a lot of people are doing that.
Online resources for like a mini curriculum, if we haven't done this
We,
before, you know?
we do have a lot of resources. In fact, we got a whole bunch of slides on resources, and we can.
Thank you.
Okay. How are we doing for time? Yes,
When you
sure.
say it's a whole year course, is it every day for an hour kind of thing, or
Yeah, that's the way I'm teaching it right
an
now.
hour a day for a year?
Because they'll be spending a lot of time working on their projects. There'll be things that'll hang them up, and they're going to need to work on them for a few hours and work through them. You know, all kinds of data structures, arrays, you know, all kinds of things, you know, that I can't even remember what the problems are, but they're right there. You know, they're all over the place. But they get through them. All right. I would make sure that you do some kind of a road show with kids. I would try to attract kids that are enthusiastic and high level if you can. I know that we all want to have high level kids. We all do, you know. Even the kids, I wouldn't go after the real low level kids because there's a lot of logic, there's a lot of computation, there's a lot of planning, there's a lot of maturity involved in, you know, working with a structured programming language. I had mostly juniors and seniors, and it worked out real well. The older kids tend to be a little bit more mature and can handle processes like this. But then again, I come from a school that has very, very low performing indicators. So I don't know what your school looks like. I don't know what your kids would be like. But they should be somewhat mature, be able to sit down and learn. But they'll be enthusiastic. I mean, the kids, they'll be crazy. You have to calm them down when they get things working. You know, they'll be real excited about it. So I had a great time. Now, make sure your counselors put kids in there that want to be there, if you can get that to happen. You know? That's always a problem.
Good luck with that one.
Good luck with that one. Yeah.
You don't like to be a downer, but how was the mixture of male to female ratio?
I had no problem with that. Okay, I know that's always been a big thing with CSTA, and I've got kind of a different perspective on that. I had more girls in my first period class than my second period class. Okay, my first period class was smaller. But the girls did just fine. But in the gaming stuff now, the kids wanted to do a shoot 'em up game in my second period class with interceptions, and it looks like a typical boy type game. But I had a game where we had carrots falling out of the sky and a rabbit eating the carrots, and we had a barn and the animals, you know, one animal chasing another animal. I mean, I said, you think of whatever you need to. This is a collision type game. Okay, the objects have to collide. As long as they collide, they can be anything. You know, the boys think in terms of, you know, rockets and projectiles. You know, the girls think of different things, and that's the amazing thing. So I found some of my best students were girls. The best student that I had, wonderful kid, a sophomore. You know, she will undoubtedly be valedictorian of the school. You know, she had a great time, did really, really well, and had never had a computer class before. And it comes down to the thing. Intelligence is intelligence. You know, it's like if you've got somebody who's really smart, they are going to absorb the material very fast. The best kid overall, though, was my third-year student. He'd had Flash before. He'd had a lot of exposure to computer stuff before, and he was like the head engineer. You know, but this other kid did great. And so girls are just fine. You know, I have no problem.
The thing with girls and what we're seeing is, and we see the same thing with games as we do with robots. Girls like games. They just like different games than boys. Girls like robots. They just like different robots. The largest demographic of online game players in this country is middle-aged women. All right? All right. Now, doesn't come as a surprise to me because my wife is always on the computer playing games on Pogo. But, the boys' games gets all the attention because it upsets people with violence and stuff like that. But girls like games. They just like friendlier games than boys.
Yeah, I never have a problem with that. Yeah, I use the model, the game with carrots and the bunny catching the carrots in my second project to make sure that the girls had something that wasn't hostile because it is a different, type of environment, and they did fine with it. They made their own.
Challenge your boys to make girl-friendly games.
That's a good one.
They already know how to do shoot 'em ups, let's be creative, so we can't use those.
That's it.
Yeah.
And
Say, there are a couple of websites available, because I just ran a gaming institute for the humanities, for humanities faculty and some things, graduate students. There's a Games for Change website, Games for Change.
Yep.
And one of the other people who is really, really good is Tracy Fullerton. I forget what department she's in, but it's the West Coast campus of USC, as opposed to USC Classic where I teach. But she has an enormous amount of stuff out there, specifically gaming that brings girls in. So the resources are there, a lot of people working on it.
Yeah, and I'm just being friendly to the girls. I mean, working with them and letting them use whatever they want. They react well.
More
I
of
have
a
no problem.
logistic question, because when you're writing and using this on a platform, it's different interface. You're actually using a controller, you're loading up.
Yeah, that's a good.
Is there an emulator on the computer side that allows you to do that?
It's very easy. You work with your games using the keyboard. You publish your game to the XNA the development using Creators Club. Once you go ahead, Alfred can show you.
you can plug one of these into your PC.
Yeah, we did that.
If you've got a wired Xbox controller, it plugs into a USB port, so you can do that. So that's one option. You can also, there are objects to respond to the keyboard and mice as well as to the game controller. So you can, you can do it both ways. In fact,
So can you run it locally?
you
with
can run it
emulator built
locally.
in?
You can run it locally on Windows. In fact, there isn't an emulator for the Xbox, but there is one for the Zune, and there is one for the Windows Phone. So
It's 2 minutes left.
if you want to program this size device, you can do that too, and there's an emulator. This is a Zune. So.
I'm going to move a little bit fast. Good things, don't rush things like I'm doing right now. Don't skip concepts. Don't take things for granted. Don't leave the students on their own for too long. Okay.
Put on just a little.
Let me just show you. Oh, we got time. I'm sorry.
We got a little bit of time.
This thing is buzzing in my hand, and all of a sudden it's making me panic. So that's. All right. Let me show you a few things that we did this year. Like I said, we geared our attention to Infotech at Los Angeles, which was not as big a deal as I kind of made it out to seem, but they thought it was a big thing, and they wanted to prove that they could do their work. I find that if you set a goal for these kids, one of the most successful things that I've had work for me in the classroom is to find some kind of a competition and say, you're going to be competing against these kids. I don't believe that competition is bad. I think competition is good. And I think that you get the kids geared up for the competition, excited about the competition, and they'll want to perform. And you have the kids peer select. They'll take a look at their work and say, who do you think should be there? Whose work do you think is the best, and so forth. Let them see each other's work and compare it, and have them help each other. The idea of having peer tutors really has saved my bacon numerous times because, some kids just get it the first time through. They really get it, they like it, and some kids need to hear it a few more times, and if you have a couple of real sharp kids that'll help you out, you're going to have a number of days when kids are going to be working on their work. I'd say it's about a third instruction and 2/3, working on what you've been talking about. If you're a very structured person, there are all kinds of resources in the Programming Now book. There are practice tests and quizzes and all kinds of things that you can set up in a very structured way. If you're teaching an AP Java class and that's the way what the kids are used to, then by all means you could progress right down that road. And I think they'd be able to see how they could use C# or Java to be able to do different kinds of things, a real practical application. And I know that I've taught the AP class, and it's very difficult. Very rigorous. Okay. So let's see. This is some of the work that the kids did. Okay, Fernie, this is a splash screen. Okay, this is a splash screen that one of the kids in my best group, Fernie, did. Okay, and he's Mexican, and the rooster has particular significance. And so that's the trademark for the game company that they were thinking about setting up. You know, they were ambitious. One of the kids was a good artist. One of them was an expert guitarist. And he did the soundtrack for the game. And the other kid, Chris, had been in my class for 3 years, and he was the lead programmer in the group. So it worked out very well. That's the first screen they see after the emblem screen. You know, they press a key. That's the scrolling star background. And this is the sort of stuff that we did. I'll show you the game if we have time. Scoreboard they created, rotating bombs, animated sprites. The background is an animated sprite texture. The rocket is an animated sprite texture, but the way he said it basically just has a right, left, and center. Let's see, what else? Okay, we used an animated sequence. It's not like Flash. You time the bombs and you have them explode over a series of frames. So that was collision detection, you know, with the bombs. Later, he took this simple concept and added to it missiles that would fire and intercept with the bombs and the other objects. So it went from a simple spacecraft crashing into things to missiles crashing into things. So you had good and bad objects and positive and negative results. Sounds integrated as well. Yes?
So the graphics you're presenting are part of the library that is in the XNA, or these were things?
These are things the kids made. They made these graphics, except for the bomb. That was like an animated GIF that we changed into a sprite texture. You know, same idea. They created the rockets, the bombs, the star background. That's not original. They borrowed that, but all the other graphics are original, except for the explosion and the star field.
What did they use to create the graphics? What software?
They used Paint.net. Okay, or Fireworks. Okay, yeah, they could have used Paint.net for everything. Fernie, I showed him how to use Fireworks, and he got into Fireworks. Okay, borrowing code. There's a strong community of gamers developing for XNA. You can find XNA sites all over the place. Okay, some code in this game was modified from open source examples. You know, examples that people gave. I would encourage you to download those, use them, show the kids how they work. You know, it'll help you too. I told you about the scrolling star field. The animated texture class came from a tutorial on Microsoft's site and was extended to fit the needs of this game. As our game got more and more complicated, we took this animated texture class and added methods and properties to it. They didn't even know what a method or property was, so that kind of made for another level of development inside the class. Let's see. All the artwork, sounds, and music are original compositions of the students. I hope maybe get to show you that. Okay, next year, I hope to add the following things to the curriculum. Add a unit on game components. I started with game components with them, and there's game services. That's kind of a more advanced topic, but it's one way you can break your code into smaller pieces and reuse your code. So you can, you know, have your own library of objects and different procedures and use them over again. Cover abstract classes, I want to do that. Cover interfaces, inheritance, and these are things that I'm sure you covered, but they're secondary when you're working with gaming. You know, you're showing them how to do things as opposed to why you do things. At a certain point, you want to go back and say, this is why you do things, this is how you make your gaming environment more efficient. Okay, kind of backtrack. Prune the curriculum for efficiency. I would throw a few things out. Okay, and I want to find a gaming competition that's accessible for them. That's a goal I have. And then maybe start thinking about 3D programming. That's a lot harder. Okay, the resources, the book. I mentioned the book. Okay. Audacity, you all have heard of Audacity, that's free. Paint.net and XNA Creators Club. Those are the resources that we used. Okay. Let's see.
Why don't you want to play here? It worked really well when I tested it this morning.
Worked on my computer.
Well, this one worked too.
I know it did.
All right, I don't know why it doesn't want to play.
Well, this is a still graphic of what should be a movie clip. Okay, that's a tutorial on Microsoft's site. They have a whole series of tutorials on XNA. And do any of you have a server in your own room or have access to a server you can set up? I downloaded all their tutorials, put them on the server, and then found out that they wouldn't play because they would only work in. Gee, which was it? What format were they? I didn't have the plugin, so I had to change them to Windows Media Format. So I found a website and I changed all of them over to Windows Media Format, and then they worked just fine. They would load up inside the browser, and then they could follow the tutorials. And that's a good way of dealing with kids that fall behind, because sometimes the kids won't quite get what you're talking about, and you can find a tutorial that parallels what they're trying to do. There's one where they create a cannon and they make this interception model. We'll play. That's okay.
It worked fine. We're running low.
10 off. Okay. Here's a screenshot of Audacity. That's sound editing software. That's free. It's also on the CD, on the DVD. You can. It's on there. You can use that. Paint.net, another free bit of software. Very good. It's also on the DVD. A lot of the stuff is on there. What I didn't put the tutorials on the DVD because they were on my iPod and I forgot where I put them. If I'd remembered they were there, I would have dragged them onto the DVD too.
What are the different formats that Paint uses?
Paint uses quite a few. PNG works real well. It'll use bitmap. It'll save in GIF. It'll save in JPEG.
It's the closest thing you're going to get to Photoshop for free.
Yeah. Yeah, it's very easy to use too. I love Photoshop. That's a great program, but this is, it's way easier and much more limited. But you have layers and so forth too. You can do lots of stuff with it. Okay, these are some of the resources. Reamer's 2D tutorial. I did a particle explosion at one of the games I was working with. That was a lot of fun. I turned that into a class, and we were able to reuse our own little particle explosion generator with the Reamer's tutorial. They did a lot of. It's kind of high-end stuff. I wouldn't hit that first. But, after a while, I'd start looking at the Reamer's tutorial. It's a real good one. XNAresources.com. Excellent tutorial. If you got the DVD, don't even worry. You're going to have this presentation. You'll be able to look at it. Okay. Game development. Alfred?
Yep. All right. Yeah, we're going to finish. I think we're going to have like 5 minutes for questions.
Huh?
Huh?
I'll load the game up later.
You'll blow the game up later. Yeah. So game development is serious computer science. It does attract kids from a wide variety of cultures, of interests. The ultimate game, the ultimate goal rather, and I think we probably all share this goal, is that we want to enable kids to be tool builders as well as tool users. We want them to be creators more than just consumers, because let's face it, the future is going to go to those people who can create new things. You alluded to games, competitions. Microsoft has a competition called the Imagine Cup. You can go to imaginecup.us and you'll see it. It's primarily college and university students, but in the game division, one of the top 10 finishers in the US was a high school team, which was really exciting, a group of kids from Maryland, I believe. The really exciting thing is they were juniors this year. Very exciting. And we've actually had a group of students won competition and went to the worldwide finals. High school students from Nevada went to the worldwide finals after creating a really excellent game for the Windows Phone 7. And the Windows Phone 7 development stuff, which does have an emulator, it's in beta now. It should be out in full bore by, sometime the end of the summer, I think. So if you're looking at phones, phones, kids love phones, Zune handheld devices, Windows computers, really there's a large variety of platforms. I have to say this stuff. So let's take questions.
May I invite people to the pilot?
Sure. This is Pat Phillips, and
we're running a pilot again this fall, and it's an online route to get help from other people that have done the pilot before and are doing it now. So I would invite you to take my card and vote XNA pilot on here. Alfred, did you kind of already do this, or do you have other plans? that I gave you.
Oh, which other disc?
I think we passed them. I think Lucky passed.
Or yes.
Did you pass out two DVDs? Yeah.
Yep, you passed out the DVDs, okay.
So if I have my card, and so when you go out, just stand out there and you can grab my card and ask me more questions. If
Right.
you have important questions, that's all.
Yep. All right, somebody over here
Any
had
other
a
questions? I'm
question.
going to run the game.
So, I'm just trying to get perspective. The earlier part of the presentation was about small basic.
Yeah.
So
Yes.
was this a single year-long course?
Yes.
You started them off with small basic?
Yes.
And then you said, okay, that's it. Now you have some programming concepts and now you can move to C#.
Yes, yes. Now, I can certainly understand why you go from Java to this. And I know that some people that were working in the pilot program learn Java first and then went into the pilot. But I did have some kids who had very, very little programming experience, and I wanted them to understand that you had a procedural language or one that you could adapt to procedures like small basic and
So
use
how
that.
was I'm really curious because I've had trouble with this from students transitioning from one language to another. So how did the basic, because when they did small basic, it was the first time they were learning about loops and variables and control statements and everything. So how did they transition? How long? So two questions really. First, how long did you have the small basic part? And then how was the transition?
Well, we started in fall. I think we went for about 2.5 months with the small basic. If I remember correctly, 2.5 months with small basic, and the rest of the year we spent with C#. I spent maybe a month with just C#, and then the whole rest of the year was XNA.
Okay.
So while you were teaching C#, did you have?
Because
you have to keep going back explaining
C#
loops and-
is the XNA is the framework that extends C#. So I wanted to show them some of the language elements of C#, and I also wanted to show them that C#, like Java, is a very full language. So I was saying, well, this is something you can do with C#. And before we get into gaming, I want to show you what other things that you can do with it and how the language works. Things like IntelliSense and building on structures is part of the whole paradigm. So when you go to XNA, they're just working with a different set of libraries and a different set of objects. But XNA is not visual. Like I think it's easier. It was an easy transition for them to go from small basic, where they would build some objects, to forms where they could see the objects and they had properties and methods and be able to utilize them, and then go to another abstraction where you have a game loop and you have to create your own objects to put them on the screen. So it made sense for me. It seemed to work.
Are there any grants or anything like that? We did some phones, we made some games for phones and that sort of thing, but if we go to the Xbox, and now we get the Xbox, and we get the new Windows Mobile 7, any grants or anything like that?
No, not right now.
Yeah, you have to try.
Have to try, and people,
try.
yeah,
This is the game.
this is the game.
Is this running off the Xbox?
No, this is
No,
running
but-
off my laptop here.
Yeah.
I thought you said there's no emulator.
No.
Well, this,
You just run it.
Well, you can run it on Windows, and then you pick how you want to publish it, and you publish it
So
for.
you can publish it for Windows or for the...
Right, yes.
So you develop it in Windows, and then when you've got it debugged and you've attached your controller to it, and you can see how you can make sure your objects work with the controller,
Yeah.
and you publish it for the Xbox.
No, I couldn't do that with Visual Basic. I couldn't publish it for a mobile phone and for the PC.
Is that I don't work with BB too much. Alfred would know.
yeah, there's some issues around different devices that you have to keep in mind. Generally speaking, you can create some games that'll go as is to the Xbox, but other games, you'll have to think differently, and we have to shut down.
Shut down. Sure, absolutely. I'm
Real
sorry.
quick question on classroom management. I assume you have around 30 kids per class, is that correct?
I had 25 in my second period and a really small first period. I was lucky, but that's a typical environment. In my web classes, I'd have that.
And in that class, you have like several different groups who are all doing different games.
Well, you give them a model, and you try to get them to develop the same basic model. They kind of create a game engine, and then you're all working with the game engine at the same time. It's too difficult to try to vary the model too much, unless once they get good and they start getting independent, then, and they're seniors, because you can't tell seniors what to do anyway, but then, you can have them branch out, and start to do things on their own.
You had no help with, like other students helping the other students?
Oh no. The kids, they love to help each other. Yeah, there's a little resistance, but I say, hey, you're gonna get some. I'm gonna give you a gold star for that. You just treat them like a little kid. To pretend they're a little kid. But
Question from over here?
yeah.
With trying to bring gaming into our curriculum and using the cell phone program, what I'm finding is, like you, I have to be careful studying, and I hit the classroom, and these kids have big ideas for gaming. Are there any plans for Microsoft or other vendors to perhaps have a teacher training kind of workshop or institute to really get us prepared for this kind of curriculum?
It's something that we're talking about. We don't have any plans right now, but it's something that we're looking at. And part of the problem is to get, enough people together in one place and make it cost effective. But we're in the process of trying to look at making some recordings and doing some things via webcasts and whatnot. So we'll like to do that.
I have an answer to this as well. Part of this gaming institute that I taught, we had Tracy Fullerton as one of our speakers. She has and if you just Google Tracy Fullerton, she will come up from USC. She has a book called Game Design Workshop that is almost a sophomore level university software engineering book, because most of what she says is don't write code until you absolutely know what you're going to do. So she spends a lot of time talking about play testing and how you set things up and how you bring the different kinds of people together, rather than just, and her statement is, when you jump in and write code first off, you spend all your time writing details of code, and you don't get to really what you want to do. And that is an issue because people think they can do great stuff. And it's hard. It is hard.
It takes a long time. But they can make a basic collision type game. They can definitely do that. And the book will take you to that point where you have a pizza game and you have collisions between different objects. And that's pretty typical of what the tutorials show too. The 2D tutorials tend to work with collision detection with different objects and a scoreboard as being level 1 type project.
All right. Let's thank the speakers.
Yeah.